Hi guys, good evening. How are you all? So, guys, I just want to introduce you all to Mansi here. She would be there, like from today's session onwards. She would be there to assist you, like to take your doubts and all, to convey it towards me. So, Shivangi has got some other some emergency job to do, so she is off for this session. So not only this session is coming, the rest of the three sessions. So Mansi would be there, who would moderate these sessions for you. So you would not find any discontinuity in that, guys. So whatever doubt you have, just put it in the chat and all, and she would get it to me. So yeah, Mansi, just you can. Introduce yourself, like what you can gonna do here, and we can start this session. Yeah, Mansi, are you able to hear me? Hello. I think, guys, she is not able to hear us. Yeah. Okay, now.
Yeah, sure. Hello everyone, I'm Mansi, and as I told you, I'm the moderator here onwards for this session. So if you have any doubts, just put it on in the comment section, and I'll be there to help you out.
Great. Yeah, thank you, Mansi, for that. So yeah, guys, so let's
Hello, yes.
yeah,
Uh,
yeah, thank you for
Hello,
that.
am I audible?
Yes, 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 we
Hello.
got you. We got you, Mansi. Yeah, we got you, Mansi. Yeah. So you are perfectly clear. You are loud and clear. Actually, we got you. Whatever you said, we got you. So yeah, guys. So let's start this session. So basically, we were discussing about class and object, and I had said you that today we are going to basically uh, do this class and object, create class and create object. Let's see this. I'll just share a screen with you and let's start this session. So I hope you're able to see this, right? So you're able to see this, right, guys? Okay, fine then. So, how about a change, guys? So this is what we have been seeing this way of thing, this setup. Okay, we have been seeing this setup. Let's change it for a while. I am planning actually to have a different setup. So who are all there in the chat today? Yeah, Atharva, Bhaskar, Gaurav, Nikhil, Sakshi, Akash, Sai Prasant, Gurtej Singh, Vinayak, Chandramouli. Good evening. Good evening, everyone there. So, how are you doing, guys? How are you doing? I hope everyone is fine and had a nice evening snacks and are all set for today's session because we are doing class and object and we'll be doing linked list today. Okay. So for a change, guys, I have also tried something new here. So we'll be seeing a new setup today. So let's see this. Let's. I don't know how do you feel that, but I have. Tried this one. So what about this, guys? What do you say? This setup, is it fine? Is it good? Do you like this setup? This would be our today's setup. Not only today's, I think I'll be continuing this for this rest of the setup. Athar, but today we'll first of all we'll complete linked list. Okay, class and object. We'll see how to do create class and object, and we'll do linked list, and then we can go for other things. Okay, so guys, if you like this setup, if you like this thing, so just show some love towards this setup, and we would start this session. Just fill the chat box with some emoticons. Okay, so we will and proceed further with our discussion, whatever we have to do today. Right? Okay. Nice setup, right? Yeah, great. So thanks to you all. Actually, I got this inspiration from you all. You are so enthusiastic. So I thought of, okay, let's make it more interesting. Let's make the class interesting. So let's proceed further, guys. So what I'll do today is, so we had already discussed this few things okay, just let me change this slide. So we had already discussed this oops in Python. We have no, like, we know that what is oops, what is I can you can see here what is written over here that oops is oops object oriented programming language. So basically it's a concept of classes and object. We know what is class, what is object, and we know that if we can access the members of class only through object. If we don't have object, we cannot access members of class, right? Okay, I think you read this. You just have a quick read over here, whatever it is mentioned. This is all like whatever we have completed. So we'll quickly go to this Jupyter notebook and try to code it out. Okay, I've also talked about constructor in the last class, but we haven't seen yet how we create constructor and all. So let's go there. So I hope you can see the construct like the Jupyter notebook out there. So we would let's basically begin today's session. So today is okay. Today is not February. It is today is 9th February. So it will just take a moment, guys. Just give me allow us a moment, and it would we'll get here this notebook, and we'll do something here. Basically code. Okay. Meanwhile, I'll see what all you guys are saying. Okay, I see there many of you are fond of this setup. Okay, we'll continue with this setup from upcoming sessions. Okay, I hope this notebook is up here. Okay, it would take a moment. Just give us a moment. Just wait for a moment, guys. It's almost there. Sometimes it takes time. Sometimes it initializes very quick. Yeah, now it's visible. Yes. Okay, first of all, let me change this date. Today is 9th of Feb. Very mistakenly, I have taken 6. Fine, done. So, how do we create class? It's very simple, guys. We just write here class, and maybe the class name is test. Okay. So, inside it, we can have some members. When I say members, I can have variables, I can have functions inside it. Okay. So, variables, when we declare inside a class, we call them as data members, and functions, when we put inside the class, we call them as methods. So I'll be calling data members and methods, or fields and methods. Okay, I hope you got that. So class test, and we have here like and yes, I had discussed about object creation, right? Whenever we write the statement of object, okay, how it like how basically object is created, guys. So we write if test is the class name, then we write ob equal to test, and this is how we create object. Okay, object would be created. Okay, by this statement, object would be created actually. Ob equal test. If your class is a test, if your class name is test. So I said that this statement by itself.
So there are some
Yeah,
comments that your voice is breaking.
my voice is breaking. Okay. Okay. Just give me a moment. It should not be the case. Okay. Is it now audible properly, guys? Voice is breaking still. Is it now properly audible? Just confirm, others, guys. Rest of you, can you confirm the same? Is it breaking, or is it properly audible? Okay. Yeah, guys, just confirm, and I'll continue. I think it must be fine, but as Nikhil has mentioned, voice is breaking. I just want a confirmation. Voice is breaking. Okay. So, what can we do for that? Just give me a moment. Just give me a moment, guys. I'll just fix that. Okay. Now, is it fine? Is it fine now, guys? Now audible? Okay. Yes. Okay. Great. So let's continue. Yeah. So this statement itself cannot create object. So it takes help of constructor, right? And how to create constructor in Python?
So
It's
it's clear
very,
now, I guess.
yeah, it's clear. Yes. Okay. So how to create? Thank you for that, Mansi. So we have here this class test. I want to create a constructor here. So how constructor looks like in Python? It's double underscore init. Okay, and we here have to place something called self. I'll talk about that, guys, what is self and all. And if you want to create a data member, then you have to write here self dot a equal to, let's say, 10. Okay, so this constructor over here, this is constructor in Python, guys. This is a special method, you can say. Underscore, it is not single underscore, it is actually double underscore, guys. Okay, double underscore init double underscore, and this you have to mention here, self you have to put. And if you want to create a data member, you have to write self dot a equal to 10. Self dot a equal to 10. So this constructor here will create object and it will store 10 in this data member a, right? Okay, fine. So this is our basic constructor. Then we can have some functions also, right? So def is the keyword to define a function actually, guys, in Python. Just yeah, just keep this in mind. Def is the keyword which we use to define a function in Python. And when a function is defined inside a class, we call it as a method. So let's define a method, maybe show, okay, or maybe I'll name it as get a, get the value of a. All right, so even here I need to have this self. Okay, I'll talk about this importance of self here, guys, don't worry about it. So get a self, right? So I'll just write here maybe print, or maybe I'll just return self dot a. So it would return me the value of a, guys. Okay, nothing else. If you want to take input to this a, so I can have one more method like set a, which would set the value of a. So it would take self and it would take maybe another argument. Okay, a value which I would store in a. So I'll just write here self dot a equal to x. It would make sense, guys. Just let me finish up with the other stuff, then it will make sense. So I'll create the object of class test. As I said, I cannot access any of this without object because these are members of class. So I cannot access members of class without object. Okay, note this here, self instead of this, it is self here in Python, but it works similar to this, guys. So don't get confused about that. It works similar to this. Okay, yeah, just a moment, guys, just give me a moment. Okay, yeah. So here, this OB equal to test, I have created object here. Then I need to call this get a, or maybe I want to, okay, first of all I'll call this get a method. So this is how you can call get a method by use of this object. You call this get a. So technically this get a would return you something. So basically we can print here whatever this get a method will return, I can actually print here. Okay, right? Got it, guys? I hope you understood. Then if I want to set something, if I want to set a value of a, so I can call this ob dot set a. Okay, I can call this ob dot set a. Okay, ob dot set a, and I can pass actually a value 10 here, or maybe 20. And after this, if I write ob dot get a, technically I should print this result, whatever this get a would give me, I should print it. Okay, so let's see, guys, what it does. So I'll execute it. So see, I'm getting 10. Why this 10? Because of this operation, print ob dot get a. I'm getting this 10, and ob dot set a 20. So this would basically set the value of a as 20. So this 20 is going to be passed here in x. Then this 20 would be stored in this data member a. That is what you are getting as the output here, 20. Okay, that is what you are getting output here, 20. So what is this self, guys? if you see here self, it is nothing but it works similar to this pointer and this operator in Java, this pointer in C++. So when you are calling this method using this ob is actually implicitly sent as an argument to this method, which is caught by this self. So self means current object. Semicolon is not mandatory in Python, Jagruti. So you can ignore the semicolon. You can give, you may not give. By mistakenly, I have given. So you can give, you may not give. That is not important. Yeah. So self, yes, self here. What is this work of self is you have called. See here. This 20 would be sent to X. Okay. This ob would be sent to self. When you are calling ob.setA, whenever you are calling a method using this object, that object would be sent as an argument over self. That is why we mentioned here self, so that catch this can actually catch the object actually. Okay, are you getting my point, guys? You call ob.setA, this ob would be sent to self. So self means current object. Okay, self means current object. So when I write here self dot a equal to x, that means ob dot a equal to x. Self means ob here. Next time if I call this method by an object ob1, excuse me, ob1, then self dot a would mean ob1 dot a. Are you getting the point or not? Okay, are you guys able to see here? Okay, just give me a minute, guys. Just give me a moment. Okay. Uh, some issue have come up. Let me just do that. Okay, guys. So I hope you understood this one. I hope you understood this one. Okay, fine, guys. So yeah, I guess we are having some issues, guys, and we are just facing some issues. I think. Are you able to hear me properly? Are you able to see whatever I have mentioned over here? I think that's some issue we are facing on our side. So yeah, we'll do it again. We'll do it again. Let me change here. Let me change this thing. Just give me a moment, guys. I need to fix it. Otherwise, you'll not able to get it. Okay, some issue. That's some issue here. Old setup because we face some issue. Are you able to hear us, guys? Just confirm. Just put in the chat. Am I audible to you? Yes. Yeah, guys, hello. Are you able to hear me?
Yes, so I guess there are some comments and they are saying it yes, so we
Great,
are good
great,
to
great.
go.
Yeah, sure. So, yeah, let's go there, whatever we are discussing. So, yeah, we have this class test and we are printing here like ob.getA, guys. When you are calling ob.getA, see, there is no argument over here. We are not passing any argument. Still, then, I have something here, self mentioned as an parameter here. Why do we do so? Because this ob.getA, when we call some method through object, that object would be passed implicitly as an argument. That is what would be caught by this self. So when I write self.a now, that means ob.a. Okay. So I have just created here two methods, or you can say two functions inside the class. I should call them as methods. So one method is to get the value of a, to return. I want to get the value of a data member. So this method will give me that, and this method will help me to set the value. Okay, set the value of a. Okay, so this is what we are going to do here, guys. So one will give us the value, one will set the value of a. Okay, yeah, I have zoomed it, guys. I have zoomed it. Sarans, I have zoomed it. I hope now it should be better, but it is a bit more. This should be fine. No, test.a we cannot write. We need to access through object, right? So what I said, guys, whenever you are writing ob.getA, by default this ob implicitly it is passed as an argument. So basically object is being passed as an argument here. Okay, so this self will get hold of that object. So whenever now you write self.a, this means object.a, ob.a. Okay, right? No, it is not necessary. I've just written here so that we'll have a clear idea about this thing, like how can we access data member, how can we yeah, how can we get the value of a, how can we set the value of a. You can actually do it directly. How? Let me just show you once again. I'll just have this much. Okay, let me copy here only this much, and I'll create a test object of test class. Okay, let me I'll create one more object, let's say ob2, and this is ob1, let's say. So I'll just write ob2 equal test. So I can do here one thing, guys. ob1 dot a equal to 10 or maybe 20, and I can write ob2 dot a equal to 30. And if I want to print, I can just write here ob1 dot a, sorry, ob1 dot a, and I can write ob2 dot a, and if I execute this, see, I'm getting 20 and 30. Okay, got it? Yeah, there is something called like, not all the access specifier are there, but you can have some, like there is no specifically access specifier. You cannot use public private thing, but some other ways you can use. I don't want to get into that because it's just we need to understand class and object, which you can apply here in linked list question. That's all. So guys, this is it. This is a class, and this is like how we create two object, and through object I can now I access this data member. I access member of the class through object, right? I cannot write only a equal 20 or a equal 30. So I need to have an object to access that. Then I'm printing the value of ob1.a and ob2.a. Okay. So one thing we are clear here, that let me tell you here. So for that I need to share another screen, guys. Okay, I need to share another screen, so let me share it. Yeah, are you guys seeing the Microsoft basically the whiteboard? Sorry. Yeah, so just say hi to whiteboard. Hi, hello, hi whiteboard, we are back to you. So we have to now take help of whiteboard to understand some few things here. Is self mandatory? Yes, Nikhil. When you are calling some method through object, self is mandatory, because I said by default, automatically this object would be passed as an argument there. Okay. So see, guys, when you have a class test and when you have a member, let's say data member, let's say X. Okay. Yeah, so when you have a member X, so when you create two object, like I have created there, ob1 equal to test and ob2 equal to test. So this would be ob1, this would be ob2. So each object will have its own copy of X. So when I write ob1 dot x equal to 10, so 10 would be stored here. x of ob1. When I write ob2 dot x equal to 20, 20 would be stored in x of ob2. So ob1, ob2 will have its own copy of x. They are different. That is why I said in the last class, each object will have different state, different data. X here, data member, it is data. So they have different data here, guys. Okay, that's what I meant to say here. So I hope this point is pretty much clear, how to access object, how to create object, how to access the data members and all. And if you're calling any method of the class, then we have to mention self as an argument there, guys. Okay, not only here, if you might have if you might have noticed in the Jupyter notebook while I created the constructor there, if you see there, even there, I have mentioned self as an argument here. Why? Because when we create object, when I write ob1 equal to test, this ob1 would be passed as an argument by default. This self would catch that. So when I write now self dot a equal to 10, is basically 10 would be stored in a of ob1. Okay, next time when you create ob2 equal to test, so basically now if you say self dot a, this means ob2 dot a. So self always means the current object, guys. Okay, that depends on through what object you have called the method. Depending on that, self would refer to the current object. If you have called through ob1, self means ob1. If you have called the method through ob2, then self would mean ob2. That's all. Okay, right? Got it? So one question I got from HM Classic Cartoon. So I'll just here mention 10 and 10. Maybe okay. Let's this make as 5. So if I do this, so is asking whether I'll get same address or different address. Okay, let's see this. I can print address of, right? So if I now hit this, see what we got. Same, right? Okay, clear? So we are getting basically the same address over here. Got it? Okay. So Python has this feature of like if we are getting same value, then it actually makes only one memory and it is being shared over here. But technically, if you talk about something like if you change the value and all, normally different object will have different value. That's why we create different object. Otherwise, we'll have just one object. Why to create two objects if we need to have one value? So if I create obviously two different value, which is supposed to be there, different object, different data, so I'll get different address. That's all. Okay, right? So this is what we had to discuss, basics of this, how to define a class, what like how to create object, how to access members of a class, what is this self. So this way, this thing we had to discuss, guys. Okay, this is basic class and object. So let's now get into this linked list concept, guys. So for that, I'll uh, first let's understand some theoretical concept about linked list, and then we'll get back to here. Okay, I hope I have answered all the queries, Mansi, and I have not skipped any of their queries, I guess. If I
Yes,
have
sir.
skipped,
Yes.
please let me know. Okay, thank you for that. So yeah, back to whiteboard. Let me clear these things. We need to understand linked list, and you will now understand why I went for this oops. Okay, so before getting into this linked list, so basically we need to understand what is linked list. In order to create linked list, we need to understand linked list. Linked list is nothing but it is collection of nodes, right? Then what is a node? Node is something kind of this way. It will have two parts. One is data, and another is a link part, which can be named as next. Okay, so there would be one node which will contain a value, and this part, this I can say the data part, and this part will basically refer to one more node. So such nodes interlinked, or there is a chaining of this node, you can say, and collection of such node linked together is known as a linked list. Okay, this is linked list. So it may have 20, it may have 30, so on. So this I'll call it as a head node. This is the head of the linked list, first node. Head would always refer to the first node, you can say. And you can always go for a tail node, guys. That depends on you how you want to do. If you don't want to take tail, that is also fine. Normally we don't take tail, so it's up to you. I'll not take tail. So this is it. So we have to create nodes and link them together. So we need to understand what is node then. So this node is nothing but it has two parts. One is this data part and one is this link part, which would basically refer to the next node actually, right? That's what we have to do. So how can we do this? Yeah, you can say it contains the address of the next node, but I am not basically talking about that address and all, because no, we don't want to get into this pointer part anyway. So even reference thing and all, we also consider in the same way, guys. So let me ask you one thing, and our concept would be very much clear actually. When you are saying this next or link contains the address of the next node, I want to ask you one thing here. So guys, when I write ob equal to test, okay, what is ob here? Test, ob equal test. What is ob here? So we say when you write this statement, object would be created, and yeah, whatever data members are there, let's say x memory would be allocated for all the data members there. So what is ob here? No, next doesn't contain the data of the next node. It refers to the next node, you can say. Yeah, in a sense, whatever Assis has mentioned, it contains the address of the next node. Yeah, in a sense, that is also true. So ob, what is ob? Mostly, normally we say ob is object, but there is a thin line actually, guys. Ob is actually a reference variable. Ob is not object. Object is created by this statement, test. This would create an object. Okay, and ob we are just referring. So you can say ob is a name for that object, is a reference variable. Ob is a reference variable to that object, is a reference to that object. I can have different references. I can write ob1 equal to ob. So for the same object, I can have different references, multiple references, you can say. So ob is reference variable, and actual object is created by this one actually, this memory. This is object physically, whatever data is allocated, memory is allocated. Ob is reference variable. Okay, ob1 is again also a reference variable, you can say. So what is ob holding here? What is the value of ob? If I print ob, what will I get? What will I get here? Like here, if I write here print id, okay, if I write here print ob1 and ob2, what will I get basically? If I hit enter, see, I'm just getting some hash code, object address kind of thing. Okay, right? Different addresses, obviously. This is different address, this is different address. Okay, so you can say this we call as hash code, or you can say address of object. You can say ob1 is a reference variable which is referring to the object, that's all. Okay, so what is exactly this and all, we don't have to right now get into the in depth of this one, guys. As I said, if you want to have in depth discussion of Python, you can join our session at 8:30. There is another session going on at 8:30 p.m. It would basically run about Python. You can have more insight there. I don't want to get into the depth of Python because I have to go to data structure and algorithm, right? Okay, got it. So yeah, let's now create a node, because as I said, uh, okay, let me share the screen to you so that it will be visible to you. Yeah, okay. I hope it's visible now, guys. Okay, see here. So when I write print ob1 comma ob2, this is printing this one, like some hash code. Okay, some hash code, object address, you can say. Okay, fine. Okay, yeah. Next, let's create this linked list, guys. linked list. Okay, let's create. So see, first of all, we need to understand how to create node. We have to create several nodes, then link together, then that would become a linked list, right? Okay, see this. So I have to create a class node, which is basically when I create object of this class node, I say one node would be created. So it will have this constructor in it. Okay, so it will take this self and a data. So I can write here self dot data equal to data. Okay, so what is this data and what is this self dot data, guys? This data is a, you can say, local kind of variable, this one. Okay, this parameter. But self dot data is nothing but this is, what is this self dot data? Self dot data is data member. So we are see, you can differentiate easily through self dot data and data. When you write just data, it means this parameter, local variable, you can say. When you write self dot data, it means the data member of the class. Okay, fine. And there would be something called next, which would be initially none. So remember, we might be using C++ in C, in Java null. Here we write none. Okay, this is our class node. When I create object of this class node, I say one node would be created. So in order to have a linked list, I have to create many such node and link them together. Okay, so let's now get into this linked list class. Linked list class. So here, same thing. I'll have this init self dot data. Okay, I don't need data over here. I just need here. So this linked list class, guys, it has only one data member, that is head. Remember that head I was talking about? In a linked list, there would be a head referring to the first node. So initially it would be none. Okay, later we would add upon. So linked list has many operations. Okay, so first of all, we need to have, like, we need to create linked list and all, or maybe insert at the end or insert at the beginning and all. So delete operation, display operation, all those stuffs we have to do, right? Now currently we don't have any linked list. Linked list is empty. There is no node created, nothing. It is empty. It is blank. We need to create. Not member function, Meghna. Self dot data means the data member. Okay, if you see, when I would call a function through this, right? If I write here self dot maybe show, I will call in this way, right? If it is a function or method, if it is a method, I'll call in this way, not this way. If I just call self dot show, then that means a data member. Okay, so let's see, guys, some things about here, like this insert operation and all. So I'll just talk about insert beginning operation here. So it takes the self, okay, and the data. I'll say key, the data which I want to insert. May let it be X. So I would be talking about here insert at beginning operation in the linked list. So this is the new data which I want to insert. Okay, yeah, head is a field. Yes, head is also a data member, is a field. Head is a data member of linked list class. Data is data member of node. Next is also a data member of node. Okay, these are methods. This insert big, whichever now I am defining, this is method of the linked list class. So it accepts this self, basically an object of linked list class, and a data X which would be inserted, right? So if I want to insert a data, obviously first of all I need to create a node, because a node would be added. So let's create a node. I'll write new equal to node. So I named the object as node. I've named the object as I've named the object of node class as new, and the value inside the node class I want is X. Okay, so this thing is nothing but you have created object of node class, right? You have created node class object created. So obviously this would in turn call this init method constructor. So what it will do, so this x would be passed to this data, right? Okay, so this data would be then stored in self.data, means that object, data member of that object node. Are you getting my point, guys? Okay, let me okay, Prachi asks x is a data member. No, x is not a data member. It is basically a local variable, you can say, inside this insert beginning. It's just a parameter, just an argument, you can say, local variable of insert beginning. It is not a data member. I'm just passing the value of x again to this data. This data is also a local variable, right? In the inside this init method of node class. Finally, that data, whichever I had sent from insert function or insert method, that would be stored in this self.data, data member of node class. And self.next would be none. I'll explain this, guys. Let me finish this thing. I'll be explaining whatever I'm doing here. Okay. So yeah. Okay. So I have created now a node. I have created a node. I just have to add it to the linked list. So if I want to add to the linked list, so there are several situations which we need to take care, guys. First of all, let's say linked list is empty. If linked list is empty, then the node which you have created just now, the new node which I have created to add, that would be the very first node in the linked list, right? So head should be referring to this node. So if linked list is empty, then we are now adding the first node of the linked list. So this should be head. How can you check, guys, linked list is empty? It's simple, right? If self dot head equal to none. If head self dot head equal to none, self means current object. If current object dot head equal to none, then that means the linked list has not been created. Head value is none. That means it is not referring to anyone. That means no node is there in the linked list. Linked list is empty. So if self dot head equal to none, then this node which I've created, this new node, is the very first node I want to, like, I am going to add. So it's simple. You just can do just can write self dot head equal to new. Okay, yeah, we don't write null here. In Python we write none. It means the same basically. Actually none means nothing, nothing at all. Okay, not exactly null, but it is basically none, nothing. It is a data type actually. None belongs to none type. So self dot head, if it is none, then we store or we make this head refer to the new node we have created, because this node, new node, whichever we have created, this is the first node which I am going to add to the linked list. The head refers it. Done. Our task is done. Okay. Then you can just easily return back from the function. You don't have to do anything else, because this is the first node we added. Now we don't have to write id of x. We need to create object. HM classic, yeah, we need to create object. We have already created object of node class. We have created a node, because node contains two things. One is this data and this next part. So we cannot store this address of x in head. Head should refer to the entire node. Okay, so that node would refer to next node and next node. This should be the case. Okay, see guys, I'll just uh, let's go back to this whiteboard and let's have a quick discussion here. Okay, see here. See guys, let's say head is now none. That means there is no node at all in the linked list. Okay, now I have created the first node. Let's say data is 10 and next part is none. This is new. I say that this is new. Now I got to know that head is none. That means linked list is empty. So this must be the first node. So head should refer to new, not address of 10, address of new. Okay, got it? So we just write head equal to new, and that's all. Head refers to the this new node. Well, new is referring to this. So new value, if I copy to head, it would refer to the same node. So I now say that I've added the first node in the linked list. Okay, got it. And how do we create it? Basically, we called insert method, guys. Insert method. Okay, it has this self, and it took our data x. What is this x? X is nothing but this data which I want to store in this new node. Got it? So inside this insert method, I would first of all create a object for node, because I want to insert a new node. So obviously I need to create an object of node class. I want to create a node here. Okay. So let's create a new node of new node, right? And pass this x, because the data of the node I want is x. This x may be 10 or 20 or 15, whatever. Okay, that will take input, but I need this x value to be stored in this node data. So that's why while creating object of node class, I'm passing the value of x here. Okay, and in the node class I have this constructor init which receives self. Okay, also it receives the data, basically the data of the node. So what it does is, in its data part, self.data, it would store this data, and in next part, as it is unaware of what is there after it, what is the next node, it doesn't know now. So it would just store none in the next part. So this is basically what we are doing right now. Okay, I hope that's clear. Let's get back to our Jupyter notebook. Is there any doubt, guys? After this, it's clear, right? No doubt. Yes, new is the, you can say, object of class node, and x is being passed to take the value. Yes, exactly, Sai. Yeah, that's what exactly I was saying. Okay. So insert beginning. So first situation is linked list can be empty if there is no node at all. So you'll just make head refer to this new node. That's all, and you'll return because your task is done. Otherwise, let's say there are some node in the linked list. Then what you would do? So we have here the task of inserting the new node at beginning. Okay, so this new node should be added at the beginning. Head should refer to this new node, and next of new node should refer to the previous first node, right? Okay, so let's do that. We have already created node. So if self.head is equal to none, so head would be referring to new and will return back from the method. But if self.head is not none, that means there is at least one node in the linked list. At least there is one node. So what we have to do here? We just have to do like self. Okay, new dot next equal to self dot head. Okay, then self dot head equal to new. Okay, yeah, linked list is dynamic, Vignesh. We don't go for vector and all here. So we have this list, we have like tuple and all those are dynamic. Okay, so even list is dynamic in Python. You can add new element. There is no specific you can say there is no specific size, limited size. If you add new element, it would be added. So yeah, guys, see this. So if head is not none, that means this condition would be false. So we'll come here. Okay. Anyway, we'll come here. If you don't mention return, then we'll come here even if the condition would be true. But as we have mentioned return, then after assigning head to new, you will return from the entire method. That's all. So if I am here, that means this if condition was false for sure. Otherwise, I would have returned from the method. but I have not returned. That means this if condition was false. So new of next equal to self dot head. New node is referring to the head node now. Then I'm changing the head node to refer to the new node. So have we added a node at the beginning, guys? Have we added? Okay, have we added? So let me share this whiteboard screen again, and we would have a discussion there. Yeah, let's see this. Now we are talking about adding at the beginning. One case is we have already discussed, like when the linked list is empty. Now we are saying linked list is not empty. Okay, there are some nodes. Let's say there are some nodes, maybe one node at least. Okay, some node there. This is head node. So now we want to insert at beginning. So new node is created, right? This is new node. This is new node. New node is created. Then what we have to do here? So we need to link here. We have to add this node at the beginning. So this should point here and head should point here. That is what we have to do. Okay, that is what we have to do here. This should point, this next of new should point to the previous head, and now head should point to this new node. Then we say we have added a new node at the beginning. That's what we have to do here. Okay, so this is exactly what I'm going to do here, guys, in the Jupyter notebook, or I think I have already done that. Yeah, new of next. First, next of new should refer to the previous head. Then you should change the current head to the new node. Okay, right? Understood this, guys, or not? This is your insert at beginning. Okay. Yeah, Mansi, have we skipped any of this? Are there queries regarding this
Yes,
class and
sir.
object?
Uh, no, not regarding class and object. However, we had missed one doubt regarding linked list, wherein HM Classic Cartoon had asked, where is this linked list used in real time?
Where is this linked list used in real time? Okay, great.
Yeah.
So, see, have you seen, guys, your phone app? When you open multiple apps and like don't close it, so it would be like one after one. If you slide, it would be one after one, one after one. It would come. So basically, that is the example. That is an basically application of linked list, which is linked together. That is actually example of circular linked list. You can say, like, if you go on swapping, then I think you would end up in the previous, the first app, when you go on slide, slide, and slide. So that is basically an example of circular linked list. But yes, again, I can feel that you understand.
Even Vignesh Suresh has asked, what is generic list and XOR list? Sir, you are on mute. We can't hear you. You are on mute, sir.
Am I audible now?
Yes, you're audible now.
Just a moment. Okay, fine. So is it fine now?
Yes, fine.
So let me give you the explanation, guys, like how exactly we can do this operation. Okay. So, okay. So if we have some nodes in the linked list, okay, this is it, and this is head node, let's say. So I want to insert a new node. So obviously I'll create a new node first of all. You can put some data here, 10, 20, 30, 40, and here let's say it is 25.
Okay, so I want to insert this at this position. So let's say this is position 0, position 1, this is 2, this 3. I want to insert this new node at position 1, sorry, position 2. So basically I want to insert it here. So for doing that, what I have to do, this should point here and this should point here, right? So I need to change this thing. So in order to change this thing, I need a reference to here. Let's say I'll call that temp. Once I get this temp point to this node, I can easily do this. How? Let's see this. I'll write the code here. Please focus. New of next equal to temp of next first of all. So this linkage would be formed. Then temp of next equal to new, then this linkage will be formed, right? This is how we can insert at any position, guys. Only thing is your task is to bring this temp up to this position. And how to bring that? It's again very simple. You just start from head. Okay, start from head, self dot head, start it from here, and you can just say uh, while I, you can start from I equal to 0, and you can say I less than this position. Okay, position is 2 here because I want to insert this new node at position 2. So I would start from 0 and it will go till position -1. That means here in this case it will go till 1. For each of these cases, what I have to do is I need to shift this temp equal to temp of next. Okay, temp equal to temp of next. So initially temp would be here. Okay, I less than position, I is 0, 0 less than position, yes, 0 is less than position. So temp would be shifted, right? Temp would be shifted. Now you're here. Basically, we need to stop here, guys. But if you look the condition, I is still less than position, 1 is less than position. So temp would be again shifted, temp would go there. But I don't need that. I need to stop here itself. So what we can do is you just can change this to I less than position -1. Okay, position -1. If you write there, what happens is position is 2, 2 minus 1 is 1, I less than 1. Initially I is 0, yes, temp would be shifted 1, so temp is shifted. Next, I would be 1 now, position -1 is 1, 1 less than 1, condition is false, so I'll not shift the temp anymore. So when you come out of the loop, when the loop would get end, your temp would be pointing to the required node, guys. Okay, now you can easily write this new of next equal to temp of next. So this link would be formed, and then you can write temp of next equal to new, so this link would be formed, and yeah, done. Insert at any position. So I'll just return a code here. Okay, but you need to take care about if the linked list is empty. If the linked list is empty, you need to do the previous code what we have discussed already, how to insert at beginning, that you need to do. Okay, so just take care of that boundary conditions, like when position would be 0 and all, and you would be good to do it. There will be no worries. I hope you understood the concept. Who had asked that? Who had just asked?
So it was Anurag Singh who had
Okay, yeah,
asked
yeah, fine. I hope you
inserting
got
at
that.
position.
Yeah, yes, exactly. I hope you understood that, Anurag. Threads, threads is threads is basically a different thing, guys. Like a particular task will be divided into multiple. You can say if you have multiple tasks, then you create threads to have individual tasks. Thread is a different thing. Don't mix. We are talking about different applications which have a different task. Basically, threads belong to the same process. Okay, so don't spam unnecessary things, guys. Okay, so just to divert attention of the other people, be there, be along with me, like be with me here. Let's discuss what is necessary here. Okay, so I hope it is clear. You understood this, right? So let me quickly get back to this Jupyter notebook, and let's see what else we have to do here. Okay. I will quickly show you the display method. So if you are inserting linked list, you also need to see, right, what is the linked list and all. So def display, I'll just call list. Okay, it also takes the self. I'll say here the same thing, guys. We have to check if linked list is empty. If linked list is empty, then we don't have to display anything. So you just can give a statement that list empty, and you can just return back. As there is no node, nothing to print, return back. If head is not none, then we can actually print everything. How to do it? It's basically same. We start from self dot head. Whatever I explained now, we'll use the same logic. So we have to continuously shift this temp till the end. So while temp not equal to none, print each temp of data. Print temp of data. Okay, and I want to end with a space, and then shift this temp to next node. Okay, are you getting my point, guys? Okay, are you getting my point? Yeah, I said Sai Meghna. I just explained the concept. You can try it by your own. The concept is pretty similar, and I have written like how to access next and all. I have written the pseudocode, total pseudo. I didn't only like explain the concept. I had actually written the pseudocode. Just have to make few changes over there, and you'll get the answer. Even it is very much similar to this one. Okay, like this part, whatever I'm using, instead of here temp not equal to none, you would just have a loop there, I less than position minus one, and you'll get it. So I'm here writing while temp not equal to none, print temp of data, and end with a space. I don't want to get to the next line. I just want to print everything in the same line. Okay, and then shift temp to the next node. Print current node data, shift temp. Print current node data, shift temp. This process will continue till I reach none. I'll start from head, and this process will be continued till I reach none. So current node data, next shift. Current node data, shift. Current node data, shift. Current node data, shift. When we shift next time, maybe I'll reach none because there would be no node after all. Okay, there will be no node after all, so I'll stop there. Temp would become none, so I'll stop there. Okay, fine. So this is how you can actually go for displaying a linked list. So let me just drive this entire program. I'll create object of this linked list. Okay, I hope I've written the name of the class correct. Yeah, linked list is. So finally, we call this insert function name insert beginning, and I need to pass data maybe 20 there, and maybe once again I'll call this method insert beginning. This time maybe 10, and then I just want to display the list. So display is simple. I'll just call li dot display list. Okay, see guys, this insert beginning display list are methods of linked list class. That's why I'll be accessing this insert beginning display list through object of linked list class, li. Okay, got it. So if I hit enter, see I'm getting first 20 was added actually, and after that 10 is added. So 10 is added at the beginning of the linked list. If you want to see, I can also have display list operation called here. Yeah, see. Okay. First it was 20, then I got 10, 20. Don't think about, okay, just to differentiate. What you can do is you can just have a print statement here. Okay, right? Yeah. So first initially when we added 20, it was just 20 in the linked list. Then I added 10. So 10 has been added at the beginning of the list. Okay, right? So, guys, I hope it is understood this how to create linked list, how to insert at beginning operation, how to go for display the list. Okay, similarly, you can also go for delete beginning operation, guys. Let me just quickly show you this delete operation. So, def delete beginning. Okay, right? So pretty much similar to this insert break thing. So it would take self. As we don't have to create a node, we don't need any data. I want to delete something, so no data is needed over here. So same thing we will check here, like if it is empty, if the linked list is empty, then nothing to delete. So just print list empty and return from the method, right? If linked list is not empty, then we need to delete the first node. How can we do that, guys? Let's think about, we have certain number of node, 3 or 4 node we have, and we want to delete the first node. So if you want to delete the first node, you just have to change the head. Head should not refer to this first node anymore. Head should now refer to the second node. And we say that, okay, from that node onward now is the linked list. This first node is excluded from the linked list. We just have to do the same thing. So we write here self dot head equal to self dot head dot next. Okay, no, insert at beginning, Nikhil, we have done insert at beginning, so 10 would be added before 20, not after 20. Okay, so self dot head equal to self dot head dot next. So head will now refer to the next node of first node. First node is excluded now, guys. This is not a part of linked list anymore. That would be automatically deleted. Here we don't have this the pointer and all those concept is not there. If you don't have any reference to an object, that would be automatically deleted. Automatic garbage collection. So we just have changed the head. Okay, we made this head refer to the second node, not the first node. So this first node is deleted from the linked list, we say. Let's say that your linked list has only one node. Okay, yeah, this piece of code works when we have multiple node in the linked list, fine. Let's say that our linked list has only one node. Linked list has only one node. So will this piece of code work if I have only one node in the linked list? I have one node in the linked list and I am performing delete from beginning from the linked list. Basically, I am deleting the only node in the linked list. That means after deleting that node, head should be none again. Okay. So this piece of code, guys, if you see, it will work because yours, if you have only one node in the linked list, then head of next would be none. Basically it is same, it would be same as writing head of self dot head equal none, because this value would be none in that case, as there is no node after it. So self dot head dot next would be none in that case, right? Okay, so this is it. This is your delete from beginning operation. Got it, guys? Got this? Delete from beginning operation. So what we can do is we can just insert some more values there. Remember, guys, this is insert from beginning. Okay. So everything, whatever I'll insert, it will be inserted at the beginning. Okay. So maybe this is 40. So there is a display list here. Let me just print down. Yeah. See, 40, 30, 10, and 20 we got. Now, if I want to delete something, delete from beginning. So delete. What is the function method name? Delete beginning, right? Delete beginning. If I do here, and after that, if I just display the list again, let's see whether it is working or we got some error. Let's see. So if I now do this, okay, my bad. Let me separate. Yeah. See. So we had 40, 30, 10, and 20 in the linked list, but now 30, 10, and 20. So this 40 element has been deleted from the beginning, guys. Okay, there is no nothing there. Okay, got it. So this is how you can perform, guys. Delete from beginning and delete from insert from beginning, delete from beginning, and display list. Okay, so you can just play around something to delete from any position or insert from any position. Okay, just follow like the concept, like how we have to reach there, we have to run a loop and reach there and delete something or insert something. Okay, so you just have to think about maintaining the links, how well you have to maintain links. Okay, fine. So got it. Okay, so next, you can also delete a particular node. For that you have to search. Okay, you have to search over like where 10 is printed, or maybe where 20 is located. You have to reach there, then you can delete something. Okay, yeah, you can do this, you can do this, you can delete 10. You just have to first search. As you are talking about deleting a particular node, you can go for this. You can just search over there this 10 and you can delete it. Okay, fine. So great then, guys. So yeah, this is how we create linked list and do some basic operation. Okay, rest of the thing, as I said, everything cannot be discussed within this short span of time. We'll be talking rest of the operation and some more things in our advanced course. Okay. So yes, if you are interested for the same, please register for our counseling session. Someone from our team would reach out to you. Okay, and you would be guided accordingly, like what you need and what you don't need, or what you can do. Okay, that's what, depending on your need. Fine then. So okay, yeah, let's talk about something here, something interesting here. Okay, functions. I have not discussed functions, so let's discuss this functions in Python. Okay, as I said, guys, to create function in Python, we have to use this keyword def. Okay, basically, first of all, there are as you know, in any language, there is a built-in function. Okay, there is built-in function and user-defined function, right? Okay, there are many examples of built-in function, like we have seen length, list, max. Okay, if I have a list here like 3 5 7 1 maybe 8 kind of this. Okay, if this is the list, I want to find the maximum value in the list, I just can apply this built-in function max, which would give me the list L. Okay, I'll get this 8. So by default, it would give me the maximum element from this list. Again, if I want to know the length of the list, I can use the built-in function length, which would give me the length of this list. It will give me 5, basically the number of elements in the list, right? Okay. So these are some of the built-in functions, guys. There are some more also, but let's focus on this user-defined function, because let's discuss how to define a function in Python. So let's define a simple function which would take basically two arguments, a and b, and its task is to add them up. Okay, and print it. So it's just like this: print a plus b. Okay, then how to call this function? It's very simple again. Just call this add and pass two values 10 and 20. See, we got 30 as the output. This is how you define a function. This is how you call a function in Python. Okay, if you want to return, if you want to return value from the function, it's again very easy. You don't have to mention a return type or something like we do in C, C++, Java. We don't have to mention here return type. The same function can return. Just write your return. It will return the value of a plus b. So what you can do is you can just store the result in a different variable like this and print the result. This is one way you'll get the same result. Or what you can do is you don't have to take another extra variable. So instead of storing the result in an extra variable, what you can do is you can just directly print the result over there. Whatever that function will return, that will be directly printed. We got here directly printed 30. Got it? Okay. So this is how we define a function, guys. This is how we define a function. This is how we can return from a function. Just mentioning this way. It's very simple. I hope you already have idea about function in C or C++. It's just we are seeing the syntax of defining a function in Python. That's all. Okay. Next, one more thing I want to just discuss, that is scope of variables here in function, right? That is, let's say, if I have a function here, def fun, okay, I'll just put here pass. What is pass, guys? Pass means, see, it is a jump control structure. It means nothing, do nothing. I'm not sure right now what to put inside the function, so I can just define it and just put a pass inside it. It will not give me error, it will just do nothing, that's all. So I have a variable here, x. I've taken the value 10. Okay, then what I'll do is I'll call the function, yeah, I'll just call the function here, and after the function call, when I once I return back the return back from the function, I just want to print the value of x, or let's say I want to print the value of x before the function fun, right? And then after the function, after the calling of function fun. Okay, now it's time we define this function fun. Okay, so what I want to do is, you might have heard about this global variable in C++, global variable, right? So you can say that, okay, this x has been created outside all the functions, so this is global variable, I can access it anywhere. So in C or C++, kind of the same way. So you might go for this. I want to change the global variable here. I want to assign 20 to this global variable x. That is what I want to do, or we want to do right now. Okay, then x equal to 20. I want to change the value of global variable here. Then I just want to print the updated value here of x in function, right? In function x. So I'm printing the value of x inside the function. Again, I'm printing the value of x outside, like when I return back from the function. That's all. I just write your return. I'm not returning anything, guys, just a return statement, so that I'll come out of the function. Anyway, if you don't even write the return, you'll come out of the function. That is optional here. When we are not returning, you can write return, only return, or you may not write anything. That's same thing. So if I hit enter, see the output, guys, what we got. Initially value of x is 10. In the function value of x is 20. But once I get back from the function, I'm again getting the value of x as 10. That means the global variable x has not been changed. So this function has not actually changed the global variable. What it has done is, it actually created a local variable. When I have written here x equal 20, it created actually a local variable and assigned this value 20 to this x. Okay, right? Got it? So this is what happened here, guys. So we cannot access actually this global variables inside the function. When you write this, it will create a local variable. That's all. If you want to access the global variables, so you have to do something else. You have to mention here global x. Okay. Now you see, previously x value is 10. In the function, value of x got 20. Even after returning from the function, value of x got 20. Okay, when you mention this global x keyword, you can now access the global variable x. Okay, got it, guys? I hope you understood this point. How to create function in Python, how to like return value from function in a Python, and this scope of variables. How can you access global variable inside a function? So you just have to mention this global keyword, global x. Then you can actually use this global variable. Okay. So yeah, Mansi, we can actually roll out the quiz link right now if I have not missed out any of the queries. So we can actually, yeah, we can roll out the quiz link actually. Yeah.
Yes, sure, sure. Just a minute.
Okay. I'll also basically show them the quiz link.
Yeah, so I have rolled out the quiz link. Everyone, please attempt the quiz. And if you guys have any doubt, just put it up here.
Okay, guys, so do let us know when you are done with the quiz. Okay, so just let us know, guys, when you're done with the quiz, and we can just have one or two more things over here. Done, guys? Have you done? Are you done with the quiz? Done? Okay, great. Others? I just got one confirmation. Okay, some more confirmation I got. Okay, I hope all of you are done. I just got three responses, but I think all of you need the same amount of time. I think yeah, pretty much. I think you are done with that. So yeah, I'll just stop sharing the screen, and we would now go back to this whiteboard. Okay, so I just want to cover one more thing, guys. I'll just take more 5 minutes. Please allow me to take your 5 more minutes. This is important. I should do this. So I just want to give you a way through which you can actually solve this pattern questions. Actually, okay. So just see this. If I have this pattern, yeah, this is the easiest pattern ever you might have seen. But I'll just give you a way through which we can solve this pattern, and we can use that trick in other patterns also. Okay, just be here, just understand what I'm doing here. Okay, so just assume this as a matrix, guys. Just assume this as a matrix. Just put over these lines. Okay, I'm not good at drawing things, so just pardon me that. You can just start. You can put indices like 0, 1, 2, 3, 0, 1, 2, 3. Okay, you can just put here. Okay, yeah, Aman, we can do that quiz, another quiz in the next session. Okay, let's basically um, complete this thing. At least we can cover something, and we can have that quiz in the next class. Not an issue. Okay, we had a major topic of linked list, that's why it took so much of time. So we can have that quiz in the next class. Don't worry, we'll not skip any quiz, we'll do that. So yeah, just understand this, guys, what I'm trying to do here. So basically, yeah, so I want to see I want all of you to see this pattern in this perspective. Just assume it as a matrix thing, and we have this stars. Just consider this diagonal, guys. We need to print the stars, right? If you see this diagonal, what are the positions of I and j? So number of rows would be decided by the outer loop, and number of column would be decided by inner loop, that we know, right? Outer loop will decide number of rows, inner loop will decide number of column. So I can basically say I0, like if I say I is the outer loop and j is the counter variable for inner loop. So this is I0, I1, I2, and I3. This is J0, J1, J2, and J3. So if I go for this diagonal, what is the condition for I and j? What is the value of I and j? 0, 0, 1, 1, 2, 2, and 3, 3. Basically here it is I equal to j. right? It is I equal to j. Then if you talk about the rest of the places where the stars are printed, asterisks are printed, here if you see the condition, it is nothing but 1 0, 2 0, 2 1, 3 0, 3 1 and 3 2. So here always I is greater than j. So if you combine these two things, you'll get I greater than equal to j or j less than equal to I, right? So I can just easily write this loop as for if you talk about C, if you talk about C language, then you can use this logic, guys. You can just write for I in, okay, I'll just write the Python code, but the logic would be more of C thing. So I can just write for I in range 0 comma 4 because I want to go till 3, 0 1 2 3, and then I'll write for, okay, just give me a moment. Then I'll write the Python version also for j in range 0 comma 4 because 4 rows 4 columns 0 to 3. So inside it I will write if I is greater than equal to j or j is less than equal to I, then we print star. Okay, print star, and we want to end with a, maybe we want to end with a space or maybe null character, so that you can place here. And after completion of this inner loop, after completion of the inner loop, when I complete this inner loop, that means if you consider this row 2, okay, I value is 2, so j value would run from 1, j value would run from 0 1 and 2, right, maximum. So basically when you are out of this inner loop, you say that we are basically done with all the column of that particular row, so we can now actually go to the next line. So you can have your print statement. You can just have print statement here. That will take the cursor to the next line. So that in the next iteration again, then the next, it will start from the next row. Okay, right? This is how it works, guys. If you talk about Python, yeah, this is also Python code, but it's not more of Pythonic way of writing the code. If you talk about Pythonic way of writing the code, then it is basically, let me show you this. Okay, not this, basically. Just give me a moment. Yeah. Okay. So it's very easy. You just write for I in how many rows, guys? 4 rows, right? So I can just write 1 comma 5 so that it could go till 1 2 3 4. I think I have already told you how this range works. So this can print here this star 5 times. Okay. If I hit enter, see, I'm getting it. What happened here? When you multiply an integer to the string, guys, that string would be repeated that many times. First time I value is 1, so this star would be repeated 1 time. Next time I value would be 2, so this star would be repeated 2 times. Then next time star I value would be 3, so star would be repeated 3 times, so on. You can also go for the logic, guys. That would be like available, that would be feasible for all the languages, C, C++, Python, Java. That logic is same. I want you to know the logic, because even if the language changes, you still can code. Okay, don't stick to any particular language. Understand the logic so that you can do it everywhere, you can code it everywhere. Okay, right? So just one more addition to that which I needed to make. Yeah, I know I have taken some more time. I hope I can get excuse from you all for that, as long as we are learning something. Okay, so if I just clear this thing, and if someone asks you this pattern, earlier what we do is in C or C++, if I'm talking about, if we talk about this, first we used to write a loop, one loop for maintaining this spaces actually. Okay, like first 3 spaces, then 2 spaces, then 1 space, then no space, one loop for printing space, one loop for printing star. But here in this logic we don't have to do that, guys. Just see this here, how easily we can do that. So okay, not this. So yeah, like this. Yeah, so 0 1 2 3, 0 1 2 3, mark the diagonal. What is the position here? If you see the diagonal, you'll get, guys, I plus j equal to 3. 0 3 1 2 2 2 sorry 0 3 1 2 2 1 and 3 0. So I plus j would be 3. And if you see the bottom one, this part, it would be actually I plus j greater than 3. So if you combine this together, it would be I plus j greater than equal to 3, this whole part, right? So keeping the loop same, if I write for I in range 0 comma 4, for j in range 0 comma 4, I'll not touch the loop condition. 4 rows 4 column, so done. If I plus j is greater than equal to 3, then print star and end with a space, maybe null character, that depends on you. Okay, see guys, if you just end it here like this, and if you write here to take the cursor to the next line, if you write print here, you'll not get this pattern. Actually, you'll get the same pattern as before. Why? Because we also need to take the cursor to the right. Behavior of the cursor is to like move from left to right and then top to bottom. So we need to take the cursor here. Okay, unless you print some space or something, you cannot reach here. So for that purpose, we would write here else print space, so that cursor will print space and move right, and at the required position star will be printed. Okay, I hope you got this logic, guys, like how to print this pattern. You can actually use this trick in many patterns. Even if combination of like a big complex pattern, you can break those pattern into smaller pattern of this kind and write the logic accordingly. Okay, fine. So fine then, so this would be the last thing which we are discussing, guys. Okay, so I would maybe show you to code. I'll show you the code part, how to print this pattern in the next class. Okay, I can, you guys also you can do this, because I have already written the code, entire code in the explanation part. You can do it by your own and um, have a practice. Anyway, I'll just show you in the next class to code this and all. So yeah, I'm done with the things, guys. I'll not extend this thing anymore. Yeah, Mansi, you can just wrap it up. So sorry for taking extra time, guys. Also, Mansi, I have taken your extra time. So yeah, we can wrap it up.
No problem, sir. Okay, guys. So today, I'll just summarize what all we did today. First thing we learned about here is methods and classes. Then we moved on to how to access members of classes. Then we covered a big topic of linked list, wherein we understood what exactly a linked list is. And after that, we learned different operations of linked list, which included inserting an element at beginning, deleting an element at beginning and at end, and so on. So there were many operations, and we covered almost most of them. Then we learned how to display a list. Then after we covered a bit of linked list, we moved on to a function part, wherein functions, which are of two types, built-in functions and user-defined function, we talked about both of them, and we looked on about the user-defined function as well. Lastly, we talked about scope of variables, which basically included global variables and local variables. And at the very last, just a few minutes before, we discussed about pattern questions, which wherein so told quite easy logic and one of the easiest method to crack such pattern codes. So that's all in this lecture, and I hope you guys enjoyed this lecture, and thank you for staying us with you. Thank you very much.
Yeah, guys. So yeah, so let's meet in the next session, guys. Do put your attendance and all. Okay, let's meet in the next class, guys. Bye bye. Take care.
Bye everyone.